Hi everyone, I'm Cheryl. In this problem, we're going to be calculating the work required to stretch a spring. In this particular case, we know that a force of 20 pounds stretches a spring 9 inches, and I want to find out what is the work required to stretch this spring from its natural position out to 1 foot. So, next thing we need is a formula for work. Now, if you think about this, as you either stretch or compress a spring, more force is going to be required the further away you get from its natural position. So that tells me that the force is variable, which means my formula for work is going to be the integral from a to b of my force function dx. Now, as I said, the force is variable, so somehow I need to come up with a function for force. I'm going to make use of something called Hooke's law, which tells me that the force is proportional to the length through which it's either stretched or compressed. Now, I'm going to use the initial information that I was given to help me figure out what that spring constant is. I know that if I have 20 pounds of force, the spring will stretch 9 inches. Now, in this problem, this particular distance is given in terms of inches, but ultimately I want to see how far or how much work is done when the spring is stretched 1 foot. I need to work either in inches or in feet. I'm going to choose to work in feet. So that means that when I plug in 9 inches, I'll enter that as 3/4, because 9 inches is 3/4 of a foot. Solving for k, I'll have 80 over 3 for my spring constant. That means my force function is going to be the function 80 over 3 times x. So now I'm ready to go back to my work formula and plug that information in. So the force function is 80 divided by 3 times x dx. The only thing I need now are my limits of integration. And if you remember, we're going to be stretching this spring from its natural position at 0 to a length of 1 foot, which will be 1. At this point, it's a simple integration problem. I have 80/3. The integral of x dx is x squared divided by 2. I'm evaluating from 0 to 1. This is going to give me 40/3 x squared evaluated from 0 to 1. And plugging in the upper limit, I'll have 40/3 times 1 squared, and then plugging in my lower limit, 40/3 times 0 squared. And that leaves me with 40/3, and remember the units for work are foot-pounds. I hope that was helpful. Thanks.